thank you for the kind introduction, and also thank you for being here, for listening to me, and it's an honor. I am from the ITS world, which is not geospatial. ITS is Intelligence Transportation System. So I am about everything that is moving on your geospatial background. Everything that moves on an infrastructure is where I am working. I'm going to talk to you about Maritime ITS, which is probably nothing new for many of you, but it is a new wrapping for something that might be a new field of interest for many in your communities. I will try to say that Maritime ITS is not finished, it is in the making, but we will build it on standards. So I will try to talk you through these 5 topics. The 2 first one is why we are doing this, and the 2 next one is how we are actually making it at the moment, and then try to sum up a little bit. So as many of you have been mentioning so far, what is going on here? Is this a maritime picture or is it a road picture? In Norway, we have these floodings every month now, and sometimes we even put in ferries to kind of cover for the loss of the road. So we are in a new era in Norway, and this is what the EU is kind of aiming for. In 2050, they aim to be climate neutral. That means that in 2030, they will have to reduce emission by 55%. That is like crazy. It's 6.5 years. In Norway, we have had EV policies for like almost 30 years. We have reduced the emission by 4.6% over the last 30 years. So how we can reduce it 55% in the next 5 to 6 to 10 years, it's, to me, almost impossible. But anyway, transportation is a big part of this. 25% of this is coming from transportation. And the maritime component of that is even a big chunk that needs to be done something with. So, of course, regulation and clean fuel will be the kind of the things that brings us to zero in the end. But taking into account that ships have an age from 30 to 60 years, it will take a really long time before the maritime industry is actually becoming clean. So that's why we have this little red circle, or red part of the circle. We need to do something else in the meantime. And the ITS, Intelligent Transportation System, the contribution for this is to actually use each vehicle, each vessel, more than we do today. No empty space in it. That goes for cargo, goes for people transport. Better use of the ports and terminals, be much more efficient, how you can dock and move the goods and persons through the terminals and the ports is something that we are looking deeply into. This is optimizing the operations, it's integration between the modes, and it's automatization. And if we kind of do all of these things in the right order, we will have less emission, of course, but also fewer accidents and even reduced costs. So this is an important place for us to be in ITS. So most ITS kind of association have a picture in their mind. You have to use all the modes of transportation to be able to optimize the use of the transportation. So we need to take into account rail, road, and air and sea at the same time, and also the terminals and the stations that are in between. In order to integrate, we need to share data with all of these entities. To do that, we need to have something defined in each of the transportation modes that you can transfer data between. This is really hard because you have so different ecosystems in these 4 main transportation modes, and you have like terminals and ports and harbors and bus stops and stations that are privately owned in the thousands around the world. So this is a really hard task, but it is doable, and that is what Maritime ITS is all about. So in this slide, I have divided in the 4 transportation modes in each of the columns, and we have also the red one that connects the transportation modes. It's also taken over here as a little bigger picture. In the land, infrastructure and land ITS, it's very well defined what ITS is. We have rules, standards, technology that is in place. And if you talk about land ITS, most people in my community will know exactly what that is. When you come to rail and aviation and transfer nodes, which this one is called, it is much more difficult. So, well, we started with working with Maritime ITS because that's at least, Norway is a maritime country, so we can absolutely relate to this. So starting with Maritime ITS, we tried to find out what is the scope and what is the framework that capture all the technologies and regulation and standard that goes into what we can define as Maritime ITS. Because then we can create a landing place for data that's shifting between road and maritime. And we can learn from each other. And at the same time, we need to learn about how the ports and the terminals are acting into this. So there's no mode alone. There's always a connection to the ports and to the terminals in order to kind of solve the riddle that we are into. So this is kind of the outset for what we are doing in Maritime ITS. It's to look at where we can share data and how we can share data. So Maritime ITS is in the making, and we don't even have a definition for it. But at the moment, it looks like this is kind of an international cooperation to integrate a worldwide maritime digital ecosystem with interoperable products and services. Our maritime or coastal administration call Maritime ITS for digitizing their services. So they're kind of into it already. But shipping is not isolated. When you come to a port, you need to be moved to your home or to your work or to wherever you're going. So we need to connect to the land-based infrastructure and ITS. So that gives us two definitions of this. The first one is to establish a Maritime ITS architecture that combines the geospatial-based standards, the nautical, operational, and administrative domains into one integrated system for sharing of data. On the land, we have SiA and SiCam in Europe that kind of package this in. So we need to find something similar in the maritime environment. And it will be based on geospatial data. And also to connect this Maritime ITS entity to the land-based ITS architecture at the same time. This is the way we are kind of doing that. And to move on to what we are doing, we have, since 2018, we have had a project going in Norway which we are called ISTS, Intelligent Ship Transport System. That is the first project that we have that is trying to kind of map up what Maritime ITS is. So we have divided that entity into 5 parts. That's the red letters on the screen. First, you have the onboard systems on the ship. That is not in our focus at the moment, but e-navigation, how you traverse the oceans and how you dock and everything. The e-navigation is a really crucial part of this. The other crucial part is the data transfer between the ship and shore, to be able to make sure that the ship is entering a port at the right time and with the right cargo and with the right services ready on shore. The other one is to kind of make it possible to connect the automated harbor and terminal operations in the future directly to the ship operations that is there. And the 5th one is, of course, the security and open data sharing to ensure that the standards are harmonized and in place. So this project aims to make that first dent in the architecture that we need. So we have another national project going on in Norway at the moment, National Digital Port Infrastructure. I think that's similar in many other countries that we do the same thing. But here we are mapping up the harbor, very accurate, and we kind of pinpoint exactly where the bulwarks are, where you can fasten the ship, and also the berth place where it should be. And imagine that there is no person in the future kind of telling the ship where to go. So it needs this information in detail and conveyed electronically to the ship. Maybe it's an autonomous ship also. So that's why we are kind of mapping up all the cranes, the fenders, the security facilities, and everything that is important to have an automatic ship operation in the future. Similar, Professor Sang Ki-hong, which is here, also kind of introduced a new way of looking at this from an operational side, to have the operation standardized from the gate of a port all the way onto the ship. This is very complementary to the one I showed you before, because here you can help standardize all these different areas that the goods or the passenger has to move through to actually get from the gate to the ship. Also very important to standardize each part of this and identify which belongs to what. So I think we have a lot of fun in front of us, Sanki, in doing this project together. And we have, or we are a part of a pretty large initiative that is to make a digital infrastructure or a corridor from Singapore to Rotterdam. That is kind of showcasing how you, based on one ISO standard, can make sure that the ship receives the optimal information on, or information to make the optimal route choices depending on currents in the oceans, the weather, the port's readiness to kind of receive the ship and everything that is needed. So you can do a very efficient run of the ship, the right speed, the right course, and everything that is needed to actually diminish the ship's emission from the ship, and also that you are in the port exactly as long as you need, that you're not there for an excess of time or use resources that you could avoid using. So this is a very interesting project that we are entering into at the moment. So the standards, and the first speaker in this session, C.V. Hong, kind of taught us how to use the S100 series of standards, and these are really important. But how can we make sure that we can look at the standards in the geospatial, in the ITS, and in the maritimes at the same time, and make sure that we can kind of connect them somehow? We already have in place a joint working group between GIS and ITS, which is convened by me. So we have worked on that for some years. Maybe we also can do something similar when it comes to the ship and maritime operations. Maybe we need some kind of working group that looks at how ITS standards and geospatial standards work together with the maritime entities and standards. So this is not a suggestion, it's like a thought. We are doing this we are doing this already to some degree, but maybe we should do this in a more kind of formalized setting later. So this makes up most of my presentation. We have a little sum up on the end here. And that is to kind of pay attention to and have respect for all the projects and all the kind of work is being done all over the world that is, in fact, a part of Maritime ITS, but they don't use that kind of wording or that phrase. So there has been doing work in Canada, in Finland, in the Netherlands, in France, Norway, in Korea, in Japan, and China, and Singapore, that we know of. OGC has a program of this that is really impressive. And I don't mean to package all of this into one thing and then say this is it, but they are all contributing to making maritime a technological concept with its own actors, its own projects, its own standards. And doing that, we believe that it will drive automatization and enable cross-mode data sharing, streamline logistics, in a much better way than it has been done so far, because now it's scattered, these initiatives. So there will be new professions, probably in the future. We will have summits, seminars, and excursion. We will do things together. We will have support from probably ISO, IHO, OGC, and all the rest. And finally, there will be less emission. So this concludes my presentation in exactly on time, I hope.